For example, we use valid, convolution or correlation. We take 3 by 3 grid and place it over here, we'll get 0. And for this matrix only, if we will take again 0 weight, or for the other matrix we will take, we will get 0 only. So whatever the derivative of this with respect to weight, that means whatever the weights are there in this filter, we are getting same input, that means same weights itself. Input means this only, we are getting again this only. So output, this output is convolution operation of image and filter. This is image and filter. So whatever the weights are there with respect to that we are doing, so that is the independent variable and this is a dependent variable. So loss depends on, we are getting again input only, because whatever the thing we do, like if weights are present, we are getting again the weights itself, that means input itself. Input is nothing but weights only, right? Weights or filters here. Now what happens is convolution operation nothing but taking this part and running down this, and next slide invalid stride length is 1 for suppose, it will go like this for valid thing, and then it will go down, but for full it will go, but here it's 3 by 3 and 3 by 3, it should perfectly merge. What I'm saying is, if we have something like this, if you have 2 by 2 filter, it will go something like this, then here, here. But if you have 3 by 3, at first only it will go here. But if you have 2 by 2, it will start from here, then here, and then here for full. For valid it will not. At first we have what I said for valid, it will go here, but for full it will start from here. And for 3 by 3, for valid also, for valid it will start directly from here. For full it will start from here, then here, and the dimension will be more. But here in this case 3 by 3 only will get, because the same thing we are getting again. So that operation has been explained over here with filter x5. This in summation is just like we need to go from here to here, that thing is explained. So you can take 2 by 2 also and perform here, sum of the products. So products are there, sum of the products. The window operation has been explained over here, that's it. Now the derivative of out, this thing with respect to filters or weight, this thing is nothing but image itself, right? We are getting the image only again. So for example, if we have filter over here 1, then what happens is, whatever the 2 value is there, it will come over here, right? If we have 0, means 0 will get. So if this value is turned on for suppose 1 or 10 for suppose, we will get 20. So we are getting image input itself. Here I have said is input of this filter only we are getting if we have all the values 0. But if we will turn on one of the bit or one of the things, like if you give weight to one of the pixel over here, it depends totally on this input image only, 2 into 10. For example, I'm just taking 1 only, then we will get entirely 2 as the answer, right? So we will get whatever the part present in image, that we will get. So changing the weights will directly it will not give weight values, it will multiply that value with image input, and again we are not getting this one totally, right? What I mean to say is, if we have something like this, and if I have some filter 0 0 1 0, and here we have values like 1 2 3 4 5 6 7 8 9, and if we pass through here, we will get values 0 0 0 4, we will get 4 over here, right? And then if we will go over here, we will get values 5, and if we will go, we will value at 7. If we go over here, we will get value 8. Now we are getting what? The values directly from here only, right? 4 5 7 8. So input values only we are getting. But if we have one more turned on, so we are not getting 1 and 1, or if you have 2, this weight as 2, we are not getting 1 and 2, we will get 2 into 2 4 plus 1, so we will get 5. And if we have over here 3 into 2 6 plus 5 11, and here if we go, we will get 2 into 5 10 plus 7 17. If we go to over here, we will get 2 into 6 12 plus 8, so 20. So we get 20, right? So previously it was 8, we will get 20. So we are not getting 1 2 values. This is just giving an impact to input, whatever the inputs are there. So input actually is 4, now it's turned to 5. So because the input, these two are giving the impact for this region. So it depends on image mostly than the weights. So what are the changes in the weights? Derivative of out with respect to derivative of weights, or derivative of out with respect to weights. So whatever the derivative of outs with respect to derivative of weights, or derivative of out with respect to weights, we'll get in image itself, and again in that region. If we are performing this region, that particular region's weights which are there, that will get. So that only we have shown derivative dl by dw, and again output is the main thing. So here, from here only we'll find the loss. So dl by dw is nothing but dl by dout, then dout by dfilter, right? Because first we need to find dl by dout, then dout by dfilter is nothing but what we have found over here. So for finding dl by dw, first we need to find the loss with respect to output over here, and that is nothing but max pooling. It will be given by max pooling.